Okay, now we're going to look at charging by conduction and how grounding works. So conduction means essentially touching. We're going to bring objects together, which will allow the transfer of electrons from one to another, and therefore rebalance the overall charge of the system. Again, the total charge of the system must stay the same, but it can transfer between different objects within the system. So in the first one, we have a metal sphere resting on an insulated stand, kind of like the pictures down below. Hold a metal bar with an insulating handle. Use the metal bar to charge the metal sphere by conduction. So what's the process? We are going to charge the bar, and then we're going to contact it to the sphere. We don't have to rub the bar and the sphere together. That's not going to charge it. We have to have a charged object, in this case the bar. So the first step would be to charge the bar in some way. And then we're going to use touch to transfer electrons from one object to the other. So conduction simply means we're going to provide contact between them to allow the electrons to transfer. Here in the picture below, we charge the negatively charged metal rod, holds a negatively charged metal rod, these are the negative charges, by its insulating handle and touches it to the metal sphere. That's going to allow electrons to transfer. They're going to want to get away from each other, so they're going to transfer onto the sphere. Now because it's metal, those electrons don't want to stay in a group. They want to get as far away from each other as possible. So they're going to spread out evenly on the surface of the sphere, and that's actually going to mean that there's no charge here in the middle. It's going to all be on the surface. Now if this had been an insulating sphere, the charges would have stayed right in one spot because they wouldn't be free to move around. Okay, so diagram A is the charging step. So again, it's the electrons are going to move. In this case, they're going to get away from the negatively charged rod, so they're going to move from the bar into the sphere. When you pull the bar away, then the metal bar is still going to be negatively charged, but it's going to have lost some of the electrons that it did. So notice this is different than charging by friction. In friction, each object ended up with opposite charge. In conduction, both objects end up with the same type of charge, but they're going to have, each one's going to have less than the individual one did, the beginning one did. In picture C up above, again, the reason they're going to want to spread out is it's a metal sphere. Metal is a conductor. The electrons actually have a force of repulsion between each other, so they're going to be pushed away from each other. The farthest they can get away from each other is to be on the surface of the sphere. They can't leave and go into the air, so they all spread out on the surface, leaving the interior of the sphere not charged at all. Okay, so now we're going to charge by conduction using a positively charged metal bar. Now this time, it's not that we're going to transfer protons onto the sphere. What's going to happen is electrons are going to be attracted to the positive charge. That's going to leave behind protons that don't have electrons, so we're going to have an overall positive charge. And the positive charge is going to end up being distributed on the surface. Now again, it's not because the proton's moving, it's because the electrons are going to vacate that area. So in diagram A, again, it's not protons move, it's electrons that move. In this case, they move from the sphere to the positively charged rod. They're attracted by the opposite charge. When you pull it away, the metal bar is still positively charged. We're still going to, anytime we charge by conduction, we're going to have the same type of charge. We're just going to have less of it. Okay, so here's two processes shown down below. Negatively charged metal sphere is touched, the hand pulled away, and the sphere is then electrically neutral. Positively charged, hands pulled away, and then the sphere becomes electrical neutral. This process is known as grounding. The finger and the hand are attached to a human body. The human body is attached to probably touching the ground. In this case, the body and the touching of the ground act as a large place where you can either draw in or put extra electrons. So in the first one, these electrons don't like to be with each other. When you touch it with the finger, the electrons are going to go through the finger into the ground, and the symbol for ground is something like that. So once you take the finger away, there's no imbalance of charge. Now in this one, same thing's going to happen, but in the opposite direction. The positive charge needs electrons from somewhere. By touching it, you're going to allow electrons to travel along your finger and in to the sphere. That's going to, for each positive charge, we'll now get a counterbalancing negative charge. When you take your finger away, it's neutral. So this process is known as grounding. When the negatively charged sphere was touched, the electrons would move from the sphere to the hand. So electrons from the sphere to the hand. When the positively charged was touched, then it's still electrons that move, so we can wipe out, it can't be the protons. But this time the electrons move from the hand and they go into the sphere, so the opposite motion. Okay, so grounding either will take electrons from the ground or put electrons into the ground, whatever it takes to try to neutralize the object. So grounding is a very important method of getting charge away from an object. The third prong on a typical electrical cord is the grounding prong, and it's not there to provide electricity, it's there to provide an escape path for electrons. So if you get too many electrons built up in one place, they can quickly escape to the ground. Or if you need extra electrons from somewhere, they can be brought in from the ground. And that is the process that we call grounding.